Hello, everybody. Welcome to the first night of the first annual Cumberland Fungus Fest produced by the Cumberland Community Forest Society. Really great to see you all here and to see people still connecting in. This is an experiment. This is an experiment in adaptation, and so far so good. Today we had kids making clay mushrooms outside and a beautiful day under the changing fall leaves, and tonight we get to tuck in at home and do a little learning together as well. So welcome for us, and we're just so thrilled by how all of you were so excited to be part of it and bought tickets. And we were also so excited by the response from the knowledge holders in the world of fungus and mycology. You know, nobody knew who we were when we decided to reach out and say, we want to do a fungus fest. And all of these amazing human beings that are becoming our friends stepped up and said, we would love to, share our knowledge and share what we've learned. And everything from university professors to hobbyists, mushroom observers and foragers and everything in between. And the other amazing thing about this whole event was it is actually a convergence of people who come from a biology and ecology perspective, converging with artists and musicians and creatives. And if you are familiar with the work of the Cumberland Community Forest Society, this is what we love to do. It seems like fungus is the right theme for mashing up art and culture and science. Moving on, our first presentation of 5 online live stream, this is happening right now, presentations is with Jason Gowen. When I first reached out to the South Island Mycological Association, am I saying that right? I think so. Mycological, there we go. A wonderful woman got back to me and said, you need to talk to XYZ. And the third person on that list was Jason Gowen because of his work and how he has ended up being a familiar face in the conversation about Deathcap observations in the South Island and the exploration of toxics in general when it relates to fungus. I'm probably not using any of the right words, but he will. So it's a pleasure to welcome to Fungus Fest, Jason Gowen. Over to you.
Well, thanks. Thanks for that great introduction. I'll start a little bit, tell you a bit about myself. I've been studying Deathcaps in the Victoria area for the past handful of years now. I kind of got into that through a general interest in mycology. When I started learning about mushrooms, my interest was in what I could eat. And it quickly dawned on me that if I was going to be eating mushrooms, I should know what I shouldn't eat and what to look out for if I did eat something that I shouldn't have. And then I quickly became very interested in the ecology of these mushrooms and the fascinating kind of chemistry of mycotoxins. I've been very involved in the online community, as I'm sure some of you already know, moderating and administrating several online identification forums. Part of what I do with that is a volunteer group that does identifications in cases where people or pets have accidentally or intentionally ingested potentially, potentially toxic species. So we get them an identification so they can get the medical treatment that they may require. Anyways, okay, so where did deathcaps come from? Deathcaps are not a native species to BC. They were at some point introduced from Europe and first recorded in BC under introduced European hardwood trees, sweet chestnut trees in the Fraser Valley in Mission in 1997, and then under beech in Victoria in 1998. That observation was actually on the grounds of Government House. It's widely speculated that the mycorrhizae of Amanita felloities arrived as a hitchhiker in the roots of European origin hardwood trees. And that's predominantly where we still see them occurring. By and large, when you're out in looking for deathcaps, where you find them is under ornamental hardwoods, boulevard trees, and in people's front yards. I've never found a deathcap in the forest. Despite that, recently Shannon Birch, who will be presenting at the Science Pub, and Paul Kroger from UBC have documented mycorrhizae of Amanita felloides with indigenous Gary oak. Mycorrhiza, for those that don't know, is a symbiotic relationship between plant roots and fungal hyphae. And the hyphae are the microscopic individual branching filaments that together make up the network of mycelium, which is the base of the mushroom organism. Given these strong associations with non-native trees and that mycorrhizae with only a single native tree species thus far have been recently recorded, the hypothesis of accidental introduction with European hardwoods seems sound. And part of what I've been doing while I'm out documenting Deathcaps and looking for new and previously unreported fruit bodies is I'm watching out for trees. I'm particularly interested to see if we can see any conifer associations. Thus far, we haven't documented any, but in other areas where Deathcaps have been introduced, they have established mycorrhizae with indigenous pine species. We have somewhat limited distribution for pines on the island. But it's something that we're definitely kind of keeping an eye out for. We'll go to our next slide. So where do we see Deathcaps? Like I said, given its predominant associations with introduced and ornamental hardwoods, we tend to see it at urban spaces, boulevard trees, well-irrigated front lawns in high-end neighborhoods tend to be the most productive locations that we see Amanita felloides in the region. Occasionally we do see it in agricultural settings where we have like tree nurseries for hazelnut, sweet chestnut, and other kind of commercial nut crops. What we do know of its distribution shows very little, excuse me, in the way of expansion outside of those urban areas, where we see not only those particular species of trees, but trees of a suitable maturity to have a well-established mycorrhizal network in their roots and producing these prolific fruitings. So part of that mycorrhizae is a nutrient exchange. And an understanding of that relationship is really kind of key to our understanding of how we can live with Deathcaps and how we should kind of deal with things moving forward. They depend on the trees and the trees are depending on them. The two are interconnected, so eradication is really not really an option. In my many years now of being involved with mushroom identification on Vancouver Island, I've seen no photographic or documented specimen collections of Amanita felloides from any rural or native forest area on Vancouver Island. All collections have come from urban, semi-urban areas, or in some cases on the lower mainland, agricultural settings. Deathcaps do, however, seem to be increasingly prolific in certain parts of Victoria and the lower mainland. And that's something that's been of particular interest to me over the past 3 years particularly. There's one site where most of the photos in this presentation were taken that I came across 3 years ago, and I found it hadn't been documented before, so I recorded it, and I checked back there. What's interesting about this particular location is that it tends to fruit much earlier in the year than other spots, and fruit throughout the year. Amanita felloides tends to be a fall fruiting mushroom, and I've seen fruit bodies produced in this location as early as June, and part of that has led to public information campaign through Island Health to alert people, and the Mycological Society, I should mention as well, to alert people that deathcaps are fruiting early and prolifically in the Victoria area. What makes Amanita felloides dangerous? Well, I think we all have kind of a good idea of what particularly makes it dangerous when we hear that common name of deathcap. Usually anything that's got death in the name doesn't have a whole lot of good behind it. Um, what makes it specifically dangerous is that Amanita felloides contains a group of toxins collectively called amatoxins, which is amanitins, which is amanitin, alpha amanitin, beta amanitin, and felloidin. And these are cyclic peptides. They're amino acid chains, basically. But these toxins have a unique kind of symptom onset that makes them particularly dangerous in the context of medical treatment. These toxins have a very delayed onset. Symptoms often don't appear for 6 to 24 hours after mushrooms have been ingested. That's a long time for your body to start processing those things and to like really make it imperative that purging early and clearing toxins is critical to the treatment. During this initial period, the toxins begin to affect the kidneys and the liver. That initial period may last for a day, and the second stage is, which is also can last around a day, is characterized by violent vomiting, bloody diarrhea, severe abdominal cramps, and as you can imagine, a large amount of anxiety. The third stage is a period of 24 hours in which the victim appears to recover, and this is a particularly dangerous point in the treatment protocols where the person appears to be recovering, their symptoms have regressed, and in some cases they've even been released from hospital. The fourth stage is a relapse, and in this point, kidney and liver failure often occurs, and this is kind of irreversible damage at this point, often fatal. Patients may bleed out and die to the destruction of clotting factors in the blood. So basically, internal damage is done to the liver and kidneys, and this lack of clotting factors in the blood makes your organs bleed out. There may be more than one relapse. So you can see that part of the problem with what makes it dangerous is that initial diagnosis. If you don't know that the mushrooms that you ate were toxic, then you don't know that anything is wrong until you have that symptom onset. And that period being as much as 24 hours delayed has a very large impact on the effectiveness of treatments. We're fortunate to live in North America, where very few people actually die from Amanita felloides or from from amatoxin poisoning. And I will mention also that deathcaps, excuse me, deathcaps aren't the only mushrooms that contain these toxins. We also see several small Lepiota species, which are little white mushrooms that occur in our lawns. We see Galerina species, which are often confused for magic mushrooms by novices. And we see Foliatina, which is another kind of common wood chip loving garden mushroom. And they all contain these same toxins in varying levels. Amanita felloides is probably the most notable example of toxic mushroom of this kind of category. In fact, there's a whole section of Amanitas referred to as section felloidea that are real relatives. We call them the destroying angels, but none of them are really known to occur on Vancouver Island. So your chances of encountering a wild deathcap or a relative are pretty slim, though this same symptom pathway could be encountered through an accidental misidentification of another species. It's important to note that there is no specific antidote to this type of poisoning, and early intervention is critical to a non-lethal outcome. Aggressive rehydration therapies have in some contexts been effective. Early evacuation of the stomach and bowel contents before symptom onset has shown to be effective. And there's been some research into using silibinin, which is an extract from the milk thistle, to protect liver function early. You have a very limited window. Really, that key point is to take away is that you should never wait for symptoms to begin. In 2003, Canada's first deathcap poisoning, a man in Victoria ate buttons growing under an English oak in his yard, believing them to be puffballs. And if you habit the mushroom identification groups, you'll see this all the time, where newcomers to foraging think puffballs are an easily recognizable edible mushroom to collect. We always encourage people to cut puffballs in half, just to avoid potential confusion with an Amanita button, just for cases like this one. 2008 was Canada's second deathcap poisoning. A woman ate a young Amanita felloities gathered on agricultural property in Langley, believing that they were straw mushrooms, Volvarelia volvacea. The host tree was not identified. What's interesting about this case, and it's not a unique scenario, is that straw mushrooms are an Asian mushroom. They do not occur in North America. They do have a very similar kind of growth pattern and basic morphology, but they have a different gill color. This has led to some speculation about immigrants of Asian descent, unfamiliar with local flora, being at greater risk for poisoning for deathcaps. But I find that kind of speculative. In 2016, this was a kind of a tragic case. It was Canada's third deathcap poisoning and first deathcap fatality. This one made national news. A 3-year-old child died after eating Amanita felloides, which was collected under hornbeam trees in downtown Victoria. These are the only documented human ingestion cases on record in BC and in Canada. In the past 2 years, however, there have been several pet fatalities in the Victoria area. And it's often when we hear about deathcaps, this is the stuff we hear about. And we hear about the dangers, and we hear a lot of sensationalism about the dangers. An interesting kind of comparison that can be made is that deathcaps have killed one person in 30 years. 15 people in Canada, according to Stats Canada, are killed by cows every year. So beware the bovine menace. How to recognize Amanita felloides. I've included this kind of basic graphic here. Hopefully you guys can see my cursor moving around, and I'll kind of point out things as we go. Key things is Amanita felloides, like all Amanita, are mycorrhizal. So that means that they're growing. They have that mycorrhizae, as we discussed earlier, that they're growing with the roots of the trees. They're part of the fungal network that provides nutrient exchange to the trees. So you'll always find them underneath the trees. You'll never find an Amanita in the middle of a field all by itself, or growing on manure or anything like that. So from the base of trees, they start off as a volva, an egg-like structure that's a universal veil. And so basically you have this encapsulation of a immature mushroom inside this egg-like fleshy structure. And as the mushroom grows, it pushes and breaks through that structure, and that leaves a sac or a cup-like basal structure, we call the vulva. There's a skirt-like annulus or ring positioned high up on the stipe. Stipe is another name for stem, and an annulus is the technical name for a ring or a skirt. In this diagram, this annulus is lower than I would typically expect to see in Amanita felloides or in its close relatives. Generally speaking, in any of the section felloideae Amanitas, like the Deathcaps and the Destroying Angels, that skirt sits nice and high up, just like under here. It's just, and that's a diagnostic feature as well. Positioning not only the presence of an annulus on a mushroom stipe, but where it's positioned on that stipe is a key thing to be looking at. They have white gills and spores, and just knowing that alone could probably have saved somebody from a poisoning if they were looking for straw mushrooms, because straw mushrooms have pink gills and spores in maturity. The cap is often tinged olive green to shades of yellow. Occasionally they're whitish or off-white, but they tend to have a kind of brassy sheen, and I hope that in some of my upcoming photos you'll be able to see that. It doesn't always translate well into photography, at least not my photography. It's something I'm working on. The stem may be white or off-white or tinged with the same color as the pileus, which is the cap surface. Something I will mention is that the cap may have remnants of the universal veil upon it. So you'll see in this lower diagram of the immature specimen, there's a big chunk of the universal veil stuck to the cap. We're used to seeing these kind of veil remnants when we're looking at other amanitas, like Amanita muscaria, the fly agaric, the kind of fairy tale red mushroom with the little white spots on the top. Those are universal veil remnants. But in section fellidae, we don't see that. We see what we call a skull cap, which is a patch of fleshy, membranous universal veil material. Often it's not present. So it's not a reliable diagnostic in and of itself, but it's something to potentially look out for. These are the growth stages, at least the early growth stages of Amanita felloides. So it starts off, as we can see, that small egg-like vulva, just like the top maybe quarter of this would have been visible above ground. And this clump of dirt around the base here is mostly actually like mycelium holding all that loose dirt together. These were all growing very close proximity to each other. So often you'll see that through a patch. They won't all be at the same stage of maturity. You'll find specimen of all different types of maturity. This little unopened button is every bit as toxic as the mature specimen. So we see here it's kind of splitting into this V groove as the cap starts to open and break through the universal veil. And now this more mature specimen, the partial veil hasn't yet opened on this one, so we don't see any ring. So if I was to flip this mushroom upside down, we wouldn't actually see any gills. It would just be a smooth white membranous surface. And then finally, as the cap opens and the mushroom's ready to sporulate, that partial veil breaks free and leaves that high sitting annulus, like you mentioned earlier. You can see how high up just underneath the cap that sits. And again, this egg-like structure at the base, that's such a key diagnostic feature. And don't eat this puffball. Before the universal veil breaks, Amanita buttons resemble edible puffball mushrooms. One key difference is that puffball mushrooms will, generally speaking, be growing above the ground. They're not buried. Most of the Amanita button at this growth stage is buried. For this photograph, I've kind of cleared away the grass and soil around the base so we can get a better look at the structure. So for this reason, you should always cut puffballs or puffballs that you're uncertain of in half to look at them in cross section. Amanita buttons will show gills and the outline of a mushroom cap in profile. I unfortunately couldn't find my photo of an Amanita cut in half for that. But an edible puffball will always be solid white on the inside, and it has a very marshmallow-like consistency. It will have no visible outline of gills, stem, or any other mushroom-like structure. Size can vary significantly from specimen to specimen. Some specimens are no more than a couple inches tall to specimen with caps 6 inches or more across. I took a picture with this lighter here for scale to show you that these are fully mature Deathcaps, and each of those is definitely toxic enough to pose a very significant health risk to an adult human, and a probably fatal ingestion for a pet. So that's kind of a good example of how, like, it can be kind of tricky to to notice if you do have Deathcaps coming up. These ones are a little bit more obvious. This specimen's pretty mature, but it doesn't look like it's got its partial veil dropped yet. Its neighbor sure has, though. So I'll mention that all of these photos were taken in one expedition, and in my preferred observation patch. This patch has spread a quite significant distance over the past few years. So are Deathcaps becoming more common? That's a question that I get frequently, and I don't honestly know. I have two theories kind of that I bounce back and forth between. And one theory is that, yeah, they're becoming more common. And the other theory is that we're just more aware of them now. We're looking for them more. There are more people looking for them. One of the great things I love about the mycology community on Vancouver Island is it's constantly growing in popularity. The Vancouver Island Mushroom Identification and Info group that I administrate on Facebook started off around 3,000 members, just under 3,000 members when I joined, and we're well over 15,000 members now. So there's a lot of people out there looking for mushrooms and wanting to learn about mushrooms. So I get messages and calls all the time saying, hey, I think I found some Deathcaps. I've kind of become the Deathcap guy. Yeah, so these in situ photos, this is under somebody's rhododendron that was right next to a big oak tree and in their front lawn nearby. So what factors may be driving this theoretical expansion? I think there's a lack of the understanding of the fungal life cycle in general. What I mean by that is, like, people have planted a lot of these host trees, not necessarily knowing that there is a mycorrhizal association with Amanita felloides that's established. And we're reaching a point, I feel, where the trees are reaching a suitable level of maturity, where the mushrooms have said, okay, now it's time to exploit this nutrient-rich situation, and we're going to fruit and reproduce. And that is the purpose of the mushroom fruit body, is to reproduce. So when we are seeing big flushes like this, it has to drive expansion to some degree. Opportune environmental conditions. This is kind of site specific. And what I mean by that is this is all in various Oak Bay neighborhoods. And where you see these mushrooms the most prolific is around the well-established mature European hardwoods in these beautifully manicured and well-irrigated front lawns in very affluent neighborhoods. So gentrification has brought death with it. Um, Landscaping and yard maintenance practices. You often see landscapers and yard maintenance companies around these sites, and I've had a couple of them come up to me and be like, "Oh, hey, what are you looking at?" And be like, "Oh, these are Amanita floydes. These are Deathcaps." And they're like, "Oh, cool!" And then they run them all over with their lawnmower, and then they hit the next 5 houses down the street. So that's just spreading more and more spore mass throughout the area, and that will definitely have an impact. If you want to get rid of mushrooms, don't run them over with your lawnmower. Um, Potentially increased attention leads to greater observation. I mean, there is that argument to be made. I will not say definitively these are factors that are driving their expansion. I believe there is an expansion. These are some of the factors that I've observed in the field that I think are driving it. But I also think that that increased attention and the increased volume of people interested in mycology and out there actually looking for mushrooms has something to do with the increased number of, oops, that's the wrong slide, increased number of observations. Sorry, I'm going to re-establish myself here. Here we go. How to address deathcaps. So we don't run them over with our lawnmower. We've established that. I've had a couple of interviews with media, and I've had some heated conversations with people that have lost pets to deathcaps, and I understand their pain and their loss, and I do feel for that. But there's often a knee-jerk reaction that like, well, we need to get rid of these, and there's really no practical way to do that. Because they're so intricately connected to the trees. They're like, unless you want to cut down all the trees and you pave everything into a parking lot, they're going to come back. And I think that education over eradication is the answer every time. And I apply that same policy to a lot of different things. So, what are some ways to live with deathcaps? How do we address them? Don't mow them over. If you need to extract them, like if you have a dog run and you found deathcaps in there, cover them. You can use even like a dog poop bag is a good example. Cover it, put in a butter knife or a spoon into the ground beside it and pry it up from underneath. Take the whole fruit body, tie it in the bag, dispose of it in the household trash. Don't compost them because you're spreading more spore mass around. Regular inspection of the space to collect any visible fruit bodies, and just awareness of the life cycle, the seasonality, and what to look for. If you don't eat them, they can't hurt you. And I've tried to explain this to a dog and it hasn't worked. But that just means it's my responsibility instead. Um, you can't be harmed from touching them. You can't be harmed from being near them. Um, Ignorance is going to cause more harm than anything else. This is frustrating. Sorry about losing my slides here. How to live with Amanita floides. Learn to recognize and reliably identify them. Have a management strategy. Supervise pets and children in areas where you know them to be. And know what to do if they're ingested and how to recognize the signs of ingestion. Hopefully toxicology brief above there was graphic enough that people will remember that symptom pathway. I will provide a few other resources here though too. Speaking of which, identification and education resources is shameless self-plug. First one is the Vancouver Island Mushroom Identification and Info Group on Facebook. Look us up. The South Vancouver Island Mycological Society. I do a lot of stuff with them, and you've got some of their premier members contributing to the Science Pub panel on Saturday. So definitely look forward to that. The Vancouver Mycological Society also runs a good website, and Paul Kroger there is a phenomenal a phenomenal source of information about deathcaps and mushrooms in general. Mycoweb.com is a Pacific Northwest-based mushroom identification resource. Mushroomexpert.com is a structured key for mushroom identification. This is more broadly focused around throughout North America though. Alpental Pictorial Keys, if you search them up through Google, they have a pretty good, they use the Pacific Northwest Key Council keys and photographs collected by members for basically an online visual field guide. Matchmaker is a great program, especially if you have a kind of a base understanding of mushroom biology or mushroom terminology. Matchmaker, you can input all the fields, describe what you see, pick colors, and it will search the keys for you, and it will give you a list of potential matches to your input fields. Current regional field guides. We have a lot of excellent field guides for the Pacific Northwest region. The current thing is basically just to avoid miscommunication with other mushroom pickers. Taxonomy changes all the time. It's an advancing science. It's a living thing. So staying current with it is kind of tricky sometimes, but try and get a guide that's been written probably in the last 5 to 10 years would be great. And the more recent the most current revision is, probably the better. And regional. Like I mentioned earlier, with the people mistaking Amanita felloides for straw mushrooms, regional differences between mushroom ecology make a big difference in your dietary choices. Also, there are numerous local workshops and great events like this one, where you can meet and talk with experts and get hands-on mushroom identification tips, advice, and learn some cool things. I would normally have some events coming up, but with COVID, I'm kind of restricting those until we kind of clear the air a bit. So what do we do if we expect an Ammonite or amatoxin poisoning? Immediately seek medical attention. Do not wait for symptoms to develop. That cannot be stressed enough. You should contact poison control. I've given the number here. I'll leave this slide up. You can take a picture, write that down. Poison control is a great phone number to have. Hey, can I get your number? Yeah, it's poison control. Retain or collect any specimen that have been ingested. So the good policy when you're trying any new wild mushroom is to set some aside that you're not going to eat. Start with eating a very small amount and then waiting 24 hours before you make a meal of anything. See how your body reacts. People have adverse reactions to commonly edible mushrooms all the time. It is by far the most common type of mushroom poisoning is people experiencing gastrointestinal distress from normally edible mushrooms. Prompt medical attention is imperative. There's no cure. Okay, there's no magic bullet. There's potential for organ transplants. There's potential for dialysis. There's potential for very involved medical treatments, but early intervention is critical to a positive outcome. If a pet has ingested Amanita felloides, keep a specimen for ID or collect one from nearby that you're confident is similar, and seek immediate veterinary attention. The North American Mycological Association has toxicological information and treatment protocols for cats and dogs available for veterinarians in cases of amatoxin and other mushroom poisonings, available on their website at namico.org. The North American Mycological Association has a really great website for general information about mushroom identifiers, mushroom poisonings, all kinds of stuff. Worth taking a wander around. ASPCA Pet Poison Control and the Pet Poison Hotline may refer you to a third-party volunteer identification service. They may also charge you a fee. That third-party volunteer identification service is going to be people like me at a group called the Emergency Help Identification for Plants and Mushrooms. We only deal with confirmed ingestions, and usually it's a vet or medical practitioner reference, but we get IDs usually within minutes. Lots of hospitals and veterinarians aren't mycologists. They don't have identifiers rapidly on hand, and when timing is critical, you want that ID quickly. I'm going to wrap up pretty quick here. I just wanted to give you guys an example of I was out 2 weeks ago taking photos in a patch, and I had a homeowner ask what I was up to. I told him I was finding deathcaps, and so he said, "Oh, hey, I think I've got some of those in my yard." And so I got permission from him, and he introduced me to his neighbor, and his neighbor said, "Well, you can come over and check my place, but if you find any, just take them with you." And so this is a grocery bag that's filled with deathcaps, and I normally wouldn't remove a ton of them. I remove those that I extract for photography, so I'm not leaving deathcaps lying around. But I've removed 2 grocery bags from this one property in 3 weeks now. So part of what I was talking about earlier is management, and this is just kind of an example of how involved that management can be. You will not get rid of the mushrooms, but if you want to have your pets around them safely, like this is what it can look like: 2 garbage bags every 3 weeks during their prime fruiting season. So yeah, I'm going to close up with that, and we'll go back to this view of the life stages. I've got a ton of other photographs and information available online on the mushroom identification group and on my Instagram page. You can feel free to join the group or reach out to me on social media. If you think you've got a deathcap, let me know, and I'll have a look. If anybody's got any questions or
if any, we have a couple of minutes for questions, and I'll start with a question. I started thinking about just introducing species and the idea of like people bringing in. I mean, I was thinking about Scotch broom, and I'm thinking about the ivy climbing up the trees and the forest behind our place. And you didn't get into it too much, but the idea of these introduced tree species, like, is that essentially what you're saying? This is all about what happens when we bring our sort of pet species from the homeland and plant
exactly.
it. But are they deadly mushrooms where it comes from as well? Like it manifests the same way wherever the source is?
Absolutely. What's our indigenous wildlife wouldn't be like accustomed to it, and definitely like there's no kind of historical attachment to it here, and it's only recently since it's been documented to have established mycorrhizae with native species that it's been actually classified as an invasive, and so that's part of where the general research is going with it now, to see what kind of impact that that may have as an invasive if it displaces native Amanita species or other mycorrhizal species, informing these associations with native trees.
Right.
How broadly it is able to establish mycorrhizae with native trees. And the other kind of interesting factor is like, aside from it being kind of a product of the displacement of natural species, or native species, I should say, excuse me, that there's probably some element at play with climate change and like how prolific these fruitings are becoming. Like every year in these patches, they're getting bigger and bigger, and they're fruiting earlier in the year and most of the year. And it's come from a point where like there was a few well established and well recognized as patches around Victoria to virtually anywhere in Victoria where I can find these tree species, I can now find deathcaps. Diane says, how does this mushroom species benefit the trees? Through the mycorrhiza. Mushrooms are really good chemists, and basically on a microscopic level, what fungi do is they eat rocks. they break down minerals, and they break them down into very, very small bioavailable bits. These are minerals and compounds that are otherwise difficult for a tree's rhizomes, roots to extract. So the fungi, they extract and concentrate these minerals, and through their interconnection with the roots, they exchange minerals for moisture and for sugars from photosynthesis from the trees. So there's a mutually beneficial exchange going on in base nutrients and moisture from the soil. The other benefit that the mushroom mycelium has to trees is that increased mycelial mass in soil density increases soil porosity and increases water retention. So soils that are rich in mycelium hold water longer through the hotter parts of the year, and it's more readily available for root growth, for new feeder root growth. So that's how the deathcaps and really any kind of mycorrhizal fungi is beneficial to its host trees. What are the trees that are in relationship with the deathcaps? Van Myco has a good list. What we see predominantly in Victoria is European hornbeam, linden, beech, sweet chestnut. There's a couple of kinds of introduced oak and Gary oak. So far, we haven't seen any mycorrhizal associations formed with native conifers or introduced conifers. Though if we look at distribution areas south of us, like in the San Francisco Bay Area, they have established mycorrhizae with some southern pine species. And in Australia, Amanita felloities is suspected to have been introduced with the rootstock of plantation pine trees. What are the tree species? Well, there's the tree species I was talking about. Yeah. Has anybody got anything else?
I had a post earlier from friends who lived up on Haida Gwaii, and there's a salmon derby happening at Copper Bay this weekend, and someone had posted about a deadly mushroom that had been found up there, but that would be a wild environment, but it was some high concern, and I actually tagged tonight's seminar. The pictures look different. It looked like a tall, sort of spindlier version of what you're describing.
And it was white?
Yeah.
Yeah, I think I saw that one come across the Amanita specialist group, and it had a suggested identification for it. It's an unnamed albinistic expression of a Amanita porphyria, I believe is what it was. I'd have to double check, but anyways, that's a potential for misidentification when we're looking at Amanita in section felloides and section vaginate. So they both have a very pronounced egg or cup-like basal structure, and they can tend to be pale, but vaginate tend to be very striate. They have very kind of defined lines radiating out from the center of the cap, but this albinistic version doesn't. And the other part of it that's unique is that, or near unique anyways, it's one of very few um, Amanita in that section that actually have an annulus. So that's something of a characteristic that's often used in field level to differentiate between those two sections of Amanita is the presence of an annulus. It's
Okay.
not a great reliable feature because that tissue that makes that ring up that skirt is very, very thin membranous, and it can be easily damaged or removed by environmental conditions. So yeah, I would like to actually see what that identification comes out as. I think that Dr. Talos, who's one of the foremost Amanita specialists, was inquiring for a specimen for that.
Okay,
So
good.
that would definitely be cool to see.
Yeah, well, I might reach back and make sure that's happening with the people that are posting about it. So we see a couple other questions,
Mm.
and you can see them too. Landscaper education sounds great, and color. So what
I
kind of go through these
I've
last few
tried to
questions and
the part of the difficulty with the landscaper education is like I have a limited opportunity to do it. When I run into them when I'm out there, I tell them what I'm up to, and if I see them kind of mowing in the area, I'll ask them if they can if they'll let me collect some specimen. I'll tell them what I'm up to, and that we're really not helping anything by running them over, but um, I haven't had any kind of opportunity for like a coordinated education seminar for landscapers specifically. There's been an increasing kind of public awareness about Amanita felloides in the area, and I don't know. I've hoped that with that awareness would kind of spread some self-education from there.
we see this
Um,
other one posted about the relationship between fungi and trees. I'm like, well, I think they should probably stick around for Shannon tomorrow night then too, right?
yeah, so Shannon's from UBC, and she actually co-wrote the paper that was the first documentation of Amanita felloides with Gary Oak. And that was in, want to say 2016 or 17. Um, I have to check. Yeah, her and Paul Kroger wrote that paper. Very cool. They found that mushroom in Saanich. Studies at UBC regarding relationship between fungi and trees about 15 years ago. There's a ever increasing amount of research into understanding mycorrhizae and ectomycorrhizae and the many many different ways that trees particularly interact and rely upon fungi. Um, Shannon's really going to be the all-star for describing those relationships in vivid vivid detail. Um, the color on the cap. Where are we? The cap can turn golden in color as it ages in place. Yeah, sometimes you see that as the mushroom kind of dries out. Like as I mentioned, it sort of had that brassy kind of sheen to it. And as the mushrooms dry, if the weather's really dry and warm, they can kind of get, I don't know. Yeah, I want to say tight. Like they look like they're drying out, and that brassy sheen really kind of develops, and they will look kind of golden. I have some photos on the I don't have them in handy for a screen share right now, but they're on my Instagram page at jroot250, and I've gone through and shown a collection of all the different color expressions of Amanita felloides that I've observed in the region.
So that's, I mean, letting us know about your Instagram page is a perfect takeaway. And I'm just wondering, maybe in the interest, like in the wrap up, I heard you speak about the potential for the relationship, not only around invasives and what that does to local ecology, but also the potential that climate change may be playing a role in increased presence. Is there a takeaway for those people that are curious about the emergence of more deadly Amanita? Is there something for those of us who are ecologists or naturalists or trying to do our best as community planners? You know, what do you want to leave us with is wisdom?
I feel like on a community kind of scale moving forward, that encouraging more planting of native species for boulevard trees and for just general greenscaping is going to be more beneficial. Like encouraging natural native spaces is going to be better for the local ecology in the long run, and we avoid more of the risk of introducing potentially harmful species. I mean, the reality is that as far as invasive species go, Amanita felloides is pretty low impact in terms of its ecological impact. It's not harming the trees, and it's just not great for us. It's not great for pets. And this is kind of a self-inflicted harm of the ways that we influence our natural environment, I guess. But I think that an important kind of takeaway is, you know, nature can be dangerous, and just that being aware of that and being aware of the risks and rewards and the kind of the varied interactions that are happening in the natural world around us is going to benefit us in the long run, the more we can like expand our understanding of those things.
Yeah, nice one, Jason. It is such a pleasure to have had you here this evening, just on behalf of the Cumberland Community Forest Society and people here who are online from all over, because that's the upside of the downside of the situation is we get to come together from all over. I just really, really thank you for your generosity with your time and for sharing with us and for supporting what we're starting off here. Thank you, Jason.
Well, I'm very happy to participate, and I look forward to seeing where this festival goes in the coming years.
Yeah, me too.